this lesson we're going to be covering graphing quadratics in vertex form. So the ones we've done up until now have been in standard form. That was standard form, you might want to write down again. Standard form was the ax squared plus bx plus c. But now we're switching to vertex form, which is when we have a times x minus h squared plus k. This looks exactly like when we graphed the absolute value functions. Only instead of it being the absolute value of x minus h, it's x minus h squared, which is going to give us the parabola instead of the v that you got for absolute value. So the things that we learned when we did this with absolute value is that h tells you the horizontal translation, so it's going to move it left and right. Remember that it moves it opposite the direction you think it does. And that k moves your graph up and down. That's the vertical translation. So h moves you left and right, k moves you up and down. A told us the vertical shrink or stretch, depending on whether or not it was a small number or a large number. It also told us if it was a reflection. The vertex was at h and k, and then the axis of symmetry is still right there through the middle through the vertex. Okay, so let's look at example 1. It says find the vertex and axis of symmetry for the graph of f of 2/3 x plus 3 squared. So what I want you to do is identify first what is a and what is h and what is k. So out to the side you're going to put a, h, and k. A is that number that's in front of your parentheses. Sometimes A is 1, sometimes A is -1, so look for those as well. But for this, our A is 2/3. So A is 2/3. H is the number that's being subtracted inside the parentheses. So since this says x plus 3, that means it was x minus what number ended up giving us a plus 3? Minus 3. So h needed to be a -3. Because if you have x minus a -3, that's what's going to make it a plus 3. And what we said when we did absolute value was just to kind of think of it as the opposite of what it looks like it is. X looks like it's positive, h looks like it's positive 3, so it's really a -3. K is what's being added out here. There's nothing there, so k is just 0. So we said the vertex is just your h and k. So this graph has been shifted 3 to the left, but it hasn't been shifted up at all. So the vertex is -3, 0. So it's just sitting on the x-axis. And then the axis of symmetry is x equals, and it's always whatever the x value of the vertex is. So x equals -3. Yes?
I'm confused. So why is there 2 pluses in front of 3?
So we were trying to figure out what the value of h is. And h is whatever is being subtracted from x. So I was just trying to show you it's x minus something. Well, it's not x minus 3, because that would still be x minus 3. If it became a plus 3, then that value needed to be a -3. That's what made it change.
So it was like condensed.
Okay, example 2, find the vertex and the axis of symmetry. So we're doing the same thing here. So let's write down what is A, what is H, and what is K. A is our number that's in front, so A is -6. Remember, what is, if A is negative, what does that tell you about our graph? There's going to be a maximum, and it opens down. Okay, x plus 1 is inside, so that means h is -1. And then this time we do have a k out there, so k is -15. So the vertex is -1, -15, and the axis of symmetry is x equals, and it was whatever that x value was, so -1. I don't know why I put parentheses around that one. I just need parentheses. So with standard form, we had to do a lot of work to find the vertex. We had to use a formula to find the axis of symmetry. We had to plug it back in to find the vertex. It took a lot. All we have to do to find the vertex on these is look at it and say, what is A, what is H, and what is K? A doesn't really affect the vertex, does it? No. Yes?
How do we know that for the vertex you have to use H and K? Wait. It's just part of the
It's part of the formula for vertex form. Okay, finding the y-intercept. In standard form, the y-intercept was just C. It was the thing that was at the end, right, that didn't have a variable. When you have vertex form, you can no longer do that. So to find the y-intercept, we have to go back to using that we know to find the y-intercept that the value of x has to be 0. So to find the y-intercept, we're plugging in a 0 for x. So y would be equal to, and we're just going to plug in a 0 where we see x. So 0 minus 1 squared plus 3. When you do that, just work through using order of operations. Do your parentheses first. So 0 minus 1 is -1. Squared is 1. So we have -2 times 1 plus 3. Then do your multiplication. -2, and the -2 plus 3 is +1.
Wait, I have a question.
So 0, 1. Yes.
Is it 0 minus 1 -1?
Yes.
Why is there a 1 in the front?
Because I squared it. So we did 0 minus 1 is -1, and -1 squared is 1. Yes.
Do you want to start our answers as a point?
If it's a point, if it's asking for a point like the x-intercept or the y-intercept, yes. Right as an ordered pair. Okay, I want you to go ahead and do example 4 also. Go ahead and find that y-intercept by plugging in a 0 for x. So on this one we plugged in a 0 for x. 0 plus 4 was 4. 4 squared is 16. We multiplied that times 1/2 and got 8. Subtracted 5 and got 3. Remember your x was 0 and your y is 3, so we write that as an ordered pair. Okay. So now let's actually graph a couple. When you look at this, how do you know it's in vertex form? What's your clue?
The parentheses and the things are.
The parentheses. The parentheses tell you this is in vertex form. You don't have to use -b over 2a. Just identify what is a, what is h, and what is k. Yes?
Can I answer?
Yes. So
Question 2.
we start with a, h, and k. Identify those first. What's our h? 1. What's our k?
0.
0. So what's the vertex?
1 and 0?
Mm-hmm. And what's the axis of symmetry?
Is it 1, 3?
X equals
Is it 1?
x equals 1. The 3 is going to affect the shape of it when we graph it, but it doesn't affect the axis of symmetry, and it doesn't affect the vertex. It determines the stretch and the shrink, just like with the absolute value. Okay, does this graph, if A is 3, does it open up or does it open down? It opens up. And is it a vertical stretch or a vertical shrink?
Stretch.
It's a stretch. So it's gone from the normal shape to being pretty narrow if we multiply it by 3. Okay, that moves all the y values up 3 times as far. So since it's opening up and our vertex is down here at 0, 1, I'm going to put my x-axis way down here at the bottom. It didn't shift very far over. The axis of symmetry is x equals 1, so I'm going to go ahead and leave my y-axis kind of near the middle of the graph. And we're going to graph the things that we know. We know The axis of symmetry is x equals 1, so we're going to graph that vertical line and label it x equals 1. We're going to graph the vertex, which is at 1, 0, right here. And then we need some points, right?
Yeah.
So before we had like x-intercepts we could plot. Well, this graph only is going to have one x-intercept, and it's the vertex. So what other point could we use?
The y-intercept.
The y-intercept. How do we find the y-intercept?
I don't know.
Plugging in a 0 for x. So to find the y-intercept, we plug in a 0 for x. So y is equal to 3 times 0 minus 1 squared. So that's going to be negative 1 squared, which is 1, and 3 times 1 is 3. And then you'll write it as an ordered pair. What was the x value? 0. What's the y value? 3. So 0, 3. That gives us 1 point. We can get another point by using the axis of symmetry. Just reflect that point over the axis of symmetry. So if we had one here, we're going to have this one over here is, oh, if it'll let me draw it, right there. And we're just going to sketch it. It's narrow, so don't try to make it go too far. Be sure that you put arrows on top. And then let's talk about the domain and range.
Are you gonna ask what's the domain and range of text?
I absolutely am.
No.
Domain and range is going to be part of a lot of these graphs from now on. So domain is the x values.
All real
If-
numbers.
Yep, it's going to go forever left and forever right. It's not going to stop going either one of those directions. So our domain is still all real numbers.
Y is greater than or equal to 3, right?
Yeah, equal
Or
to.
to 0.
Yeah, you're looking for your highest point or your lowest point. And as far as y is concerned, our lowest value of y is down here at the vertex, and the y value at the vertex is 0. The rest of the graph is above that, so all of the y's are greater than or equal to 0. Y is greater than or equal to 0 means that it's all of the graph is taking place up here. None of it is taking place below the x-axis. Okay, I'm going to give you a minute to practice graphing number 6. Okay, so you've got your A is -2, your H is 3, and your K is 4. Does this graph open up or open down? It opens down, and how do we know that? Because A is negative. So when you're thinking about where to draw your x and y axis, keep in mind where the vertex is and whether or not it opens up or down. So the vertex is +3, +4. So the vertex is in quadrant 1, but it opens down. So I might put the x-axis up a little bit higher, but not so high that I can't fit my 3, 4, and then also put in your y-axis about right there. Okay, we've 3, 4. There's our vertex. Our axis of symmetry goes right through the middle. We could plug in a 0 to find our y-intercept. It might be off of our graph. I don't know if you've found it yet.
But you're gonna have to go by 2.
Okay. So it might have been, so 0 minus 3 is -3, squared is 9. -2 times 9 is -18. Plus 4 is -14. So since that's not a great number for my graph, I might pick something else to plug in for x. The y-intercept is often really good, but sometimes there's something better. So since our axis of symmetry is here at 3, I'm going to pick something in between 0 and 3 to give me maybe a better number. So if I could plug in a 1, I could try plugging in a 1. So 1 minus 3 is -2. Squared is 4. That would be -8 plus 4 is -4. So I could use the point 1, -4, which would be here. And that might give you a little bit better
Get some paper towels.
grasp.